Okay, let us now talk about the implementation of queue. I'm going to do the same thing again. Cat. Okay. Dog. Fish. And bird. So queue is very similar to stack. So notice 1, 2, 3, 4, 5. I've implemented adding on cat, dog, fish, and bird. Very similar. When we add data into a queue, when we insert something, we call it enqueue. Okay. However, when you remove it that time, right? Unlike the stack, right, where you remove bird and ant, right? In queue, right, you remove the front of it. Cat. Let's say I remove it twice. Dog. So this is what we call DQ. So this is where we call in, right? First in, first out. Okay. So just now the previous one is first in, last out. This one is first in, first out. So now what's left remaining is fish, ant, and bird. Okay. So how do now you have a rough idea of how this queue works? How do we implement it? Okay. Let's see. So this one I took from the marking scheme. So let us now see, and I'm going to show you. So this one say how do you declare initialize the data storage used to implement queue? It okay. I'm going to talk about NQ first. So how we add from 1 to 5 first. So in this one, right, they like to call it front pointer, rear pointer. I like to make it I like it to be more straightforward. Front of queue, end of queue pointer. So one is 1, one is 0. So first thing first, they have right here, declare of array size 1 to 10. So I same thing right here. I declare my queue 1 to 10. Declare integer for front of queue pointer, end of queue pointer. I have it right here. Front of queue pointer, end of queue pointer. Okay. Okay. So initialize end and front of queue pointer. So I initialize both of them. Front of queue, I start at 1. Okay, that means the very beginning. End of queue pointer, I start at 0. Okay, I'll show you later why I start at 0. Okay. Okay. Um, declare integer, variable, or number in queue. Okay. This one I decided to use. No, this one I just follow the end of queue pointer. So this one not really needed. Declare integer for size of queue. Okay, now size of queue allowed. You see, I have size of queue allowed. I decided that the queue I make it to be about 5. The size of queue I make it to be about 5. Declare and then initialize the size of queue. So this one I will use it to be about 5. So although the queue I leave it to be about 10, right? But I just want to limit my queue a bit. I can limit it about 5, 6, but for now I just choose 5 lah. Okay. So I have 2 more extra terms. My 2 more extra terms is I have actual size of queue, size of queue allowed. So the size of queue allowed I allow 5 lah. Okay. So I decided to NQ DQ. That means to add in now. NQ, please remember again, is to adding data. So this time I'm going to add data. So we call it NQ. So first, when we want to NQ that time of we haven't, let's say it's not empty. Actual size of queue, this is 0. This is 1. So actual size is now -1. So -1 is definitely not bigger than 5. Because why is it I have this term right here? This term right here, right, is to ensure you don't you don't because we only allow 5. So if let's just say n of q pointer minus front of q pointer, let's just say 6. That means you are now want to storing 6 items. So n of q pointer minus front of q pointer, let's just say 7 minus 1, 6, which is bigger than the size of queue allowed. Instead of storing the item, right, we will just say queue is full, no more data can be stored. So that's why I have something called actual size of queue, which is n of q pointer minus front of q pointer, versus the size of queue allowed, which is we set it standard 5. So if it ever exceeded already, we'll say that queue is full, don't store any more data. Now it's, let's just say we haven't stored anything yet, -1, 0 and 1. So now what happens is that now 0 here plus 1, so it's 0 to 1. Okay, q1 put in cat, q1 put in cat. Okay. Now why got this term right here? It is because of later you're gonna see, right, when you remove, right, when you dequeue, which is removing data at that time, right, your front of queue is going to come forward. So let's just say you enqueue, dequeue, right, what happens is that your front and end of queue pointer is only going to increase the number. But because of the size of the queue allowed is 5, right, we don't want to, let's just say, go until the array until declare until 100. So what we do is having it to be a circular array. Should ever, later you're going to see, the end of queue pointer or the front of queue pointer ever exceeded 10, which is inside the array allowed, what we're going to do is move it back to 1. So what is this idea allowed leh? To allow the queue to be circular. And the queue is allowed to be circular because what is the size that we have it for? The size is 5, but the queue we set it up to 10. So we just have the queue moving around in that circle lah, in that 10 spaces. The 5 data that we want stored, always moving around that 5 circles. To move around the circle inside the array of the 10 data array of the 10. Okay, okay. So just now we have 0 to 1, we restore q1 equals to cat. Now we want to store the second one. What happens? Second one, and q again, again, now it's 1 minus 1, still 0, less than 5. So now second one is not full yet. 1 to 2. 1 to 2. So q two now equals dot. And that's how you get to 3, 4, and 5. 2 to 3, 3 to 4, 4 to 5. You store to fish, ant, and bird. And that's how you store data. And that's how you enqueue in the implementation of the queue's data structure. Okay. Now, we want to dequeue. What is dequeue? Please do know that dequeue is removing data. Okay. First thing first, please ensure. Now I restore 1 to 5 already. So my front of queue pointer is here. My end of queue pointer is here. My front of queue pointer is here. So here will be front of queue. Here will be end of queue. Okay. Again, first thing first, we must make sure the actual size. So actual size is 5 minus 1, still 4, less than 0. Not negative. It's negative, then we have to say queue is empty, no data to be removed. Yeah. So what is this for leh? This is to make sure it's a condition to ensure that the queue is neither, like the previous one, is either too full or empty. We need to have a condition for that. So this is to ensure that the queue is not empty. Okay, so now we're at 5 already. Now when we remove, right, where do we remove it from? We remove it from right here. We don't remove bird, we remove cat first, the front of Q. So because of that, right, front of Q we never change, still always remain 1, right? So Q1 has cat installed, has cat inside there. So cat is removed. Front of Q is 1 plus 1. So it is 1, 2, 2. Make sense or not? Q1 has cat. Cat is removed. Now front of Q move from cat now to dog. Okay. Again, we DQ one more time again. 2 to 3. Why? Q2 has dog. Dog is removed. So now, I want you to think about it. The front of Q first moved here. Now it moved here. 2 to 3. Dog is removed. Now front of Q is at number 3. And that's how you DQ it. Um, what's this about? This is to ensure a Q is in circular motion. To ensure the Q is in a circular motion. Okay. Okay. Now, in the array, the array still has cat and dog inside it. But a Q is from the front of Q pointer to the end of Q pointer. So I want you to remember, inside the array, right, although we say remove, right, what we did, right, is what happens is that what we did is just that we moved the front of Q from 1 to 2, 2 to 3. The cat and dog is still inside there, but it doesn't matter because what happens is that a Q, right, is from 3, 3, sorry, 3 to 5. A Q is from front of Q pointer, which is 3, all the way to 5. That's what a Q is. It's not about what's inside the array, it's from the which pointer to which pointer. And that's how you NQ and DQ. Okay, with that being said, thank you very much.